Here is an original SAT-style question. The system below contains a constant, k. If the system has no solution, what is k? For x minus 6y equals 12. And open parenthesis k plus 1 close parenthesis x minus 9y equals 5. At first, no solution sounds like the question has taken away the information you need. But on the SAT, that phrase is often the information. Let's turn it into a picture before touching the algebra. A solution to a system is one ordered pair, one x value and one y value that makes both equations true. On a graph, that pair is an intersection. Two non-identical straight lines can cross once, never cross, or sit directly on top of each other. Those are one solution, no solution, and infinitely many solutions. So no solution tells us the two lines never meet. For straight lines, that means they point in the same direction but are separated vertically. They are parallel, not the same line. That is the first useful translation. No intersection means equal slopes. Start with the first equation. For x minus 6y equals 12. Add 6y, subtract 12, and divide by 6. The line is y equals 2/3 x minus 2. Its slope is 2/3. Now use the second equation. Open parenthesis k plus 1 close parenthesis x minus 9y equals 5. Move the x term and divide by 9. Its slope is k plus 1 divided by 9. The intercept is -5/9. The important part is not the intercept yet. The unknown k is sitting inside the slope, exactly where the no solution condition can reach it. Parallel lines have the same slope, so set the slopes equal. Open parenthesis k plus 1 close parenthesis over 9 equals 2/3. Multiply by 9. K plus 1 equals 6. Therefore k equals 5. Notice what we did not do. We did not solve for x and y because the question tells us there is no shared x and y pair. We used the geometry of that missing pair to solve directly for the parameter. There is one trap left. Equal slopes can describe two different parallel lines, but they can also describe the very same line. The same line would have infinitely many solutions, not no solution. Put k equals 5 into the second equation. It becomes 6x minus 9y equals 5. Now multiply the first equation by 3/2. 4x minus 6y equals 12 becomes 6x minus 9y equals 18. The left sides match, but 5 is not 18. The equations demand the same expression to equal two different numbers. That is impossible. The lines are parallel and distinct, so k equals 5 is verified. Here is the complete map. If the slopes are different, the lines cross once. One solution. If the x and y coefficients scale together but the constants do not, the lines are parallel and distinct. No solution. If the x, y, and constant terms all scale by the same factor, the two equations are the same line. Infinitely many solutions. In standard form, the fast check is a ratio check. Compare the x coefficients, the y coefficients, and the constants. For no solution, the first two ratios match, but the constant ratio does not. For our anchor, the slope condition is the same as open parenthesis k plus 1 close parenthesis over 4 equals -9 over -6, which equals 3/2. Then compare the constants. 5 over 12 is not 3/2. Same direction, different position. Now try the method on new numbers. 5x plus 10y equals 20. Open parenthesis r minus 1 close parenthesis x plus 4y equals 7. If this system has no solution, what is r? The first line has slope -1/2. The second has slope negative open parenthesis r minus 1 close parenthesis over 4. Set them equal. Negative open parenthesis r minus 1 close parenthesis over 4 equals -1/2. That gives r minus 1 equals 2, so r equals 3. Verify the constants. When r is 3, the second left side is 2x plus 4y. That is 2/5 of the first left side, so the matching right side would have to be 8. It is 7 instead. The lines are parallel but distinct. The answer is 3. When a two-line SAT system says no solution, use 4 moves. First, translate the words. No solution means no intersection. Second, Make the directions match. Set the slopes, or the x and y coefficient ratios, equal. Third, solve for the hidden parameter. Fourth, check the constants. Same slope with a different intercept is no solution. Same slope with the same intercept is infinitely many solutions. The phrase no solution is not a blank wall. It is a geometric constraint. Once you see the two lines behind the equations, the unknown number is often the part that is nowhere left to hide.